Okay, so we're going to move on with congruence and similarity. We've got properties of similar polygons. So if something is similar, so same shape but different size, it has some characteristics. So if we look at this picture, they did a nice job of putting all the angle marks in corresponding angles. And if you look at the numbers, 5 to 10, 2 to 4, 3 to 6, and 1 to 2, that means that this second quadrilateral is twice the size. The scale factor would be 2 if we were mapping the smaller one onto the larger one. So we've got a vocab word on slide 2, and we've got some information about similar polygons. If two polygons are similar, then their corresponding angles are congruent, so same size, same shape. The measures of their corresponding sides are, there's that P word, proportional. We talked about this yesterday, that if it said ABC is similar to triangle XYZ, then we know that A and X go together, B and Y, C and Z, and we use that similar sign. We're also now saying that since they're proportional, we can set up proportions and set up ratios there. So polygons that have the same shape are called similar polygons. There's our vocab word. In the key concept box, triangle ABC is similar to triangle XYZ. This is written as triangle ABC is similar to triangle XYZ. The parts of similar figures that match are called corresponding parts, like A and X, B and Y, C and Z. Okay, so now we're going to see if things are congruent. So determine whether rectangle HJKL is similar to triangle MNPQ. Now we do know that all rectangles have 90-degree angles. This little common error box says, though, do not assume that all rectangles are similar just because all of their angles are congruent. Their corresponding sides must also be proportional. So when you explain this to me, I want you to show me your work. So we're going to do like little side over little side or big over little. Your choice. I tend to do little over big. And sometimes I do big over little, so I'm not that consistent. We know that 3 over 6 simplifies to a half. So now we need to know that the long sides, 7 over 10, would simplify to a half. Well, that's not true, so we can just write does not equal a half, and then we can just write not similar. And why? Because of that reason right there. That's showing me the ratios. Slide 4, let's try it again. Determine whether triangle ABC is similar to triangle XYZ. So I'm going to go short over big again, short side and the shorter side. Corresponding would be 6/8, which simplifies to, take a 2 out, 3/4. Well, that means that 8/12 has to equal 3/4. So if we simplify 8/12, we would take out a 4. We would get divided by, take out a 4, and we would get 2/3. Well, that does not equal 3/4, and therefore these are not similar as well. Now, if we got 2/3 equals 2/3, we could check the third side, but we've already checked it because it's a 6 and an 8. We would say that triangle ABC is similar to triangle XYZ. On the back, another vocab word, scale factor. This is the ratio of the lengths of two corresponding sides of two similar polygons. You can use the scale factor of similar figures to find missing measures or missing sides. Options if they are similar. They have to be similar. Find what the sides are being changed by either multiplying or dividing. This would be called your scale factor. Multiplying or dividing. So something like it's half the size, divide, or it's 3 times as big. That would be multiplying and dividing. Since the sides are proportional, you can set up a proportion, and we'll see that here in a second. And you have to be consistent. So little over little equals, or little over big equals little over big. Corresponding sides have to be set up. Slide 6 says quadrilateral WXYZ is similar, so that we know that these are similar. So that means that the sides are in proportion, the angles are the same. Describe the transformations that map the big one onto the little one. So, well, we would know that it has to get slid over. That's called a translation. And it got smaller. That's called a reduction, but we can call that a dilation is the better word. And I'm just going to put in parentheses, it's a reduction. Find the missing measures. We're going to do this in 2 ways. The first way is to set up a proportion. So 2 sides that we have the same, a number written on both, are we the bottom, so 10 over 15. And then what corresponds to M is the 12. So we would say we did little over big, so we have to do little over big, 12 over M. Now to solve a proportion, equal sign in the middle, we cross multiply. 10 times M is 10M. 15 times 12 is 180. Then if I were to divide both sides by 10, I would get M equals 18. No label. If I were to use the scale factor, I need to find the larger side, so I would use the sides that I know and set them up as a ratio, 15 over 10. I'm going to simplify that by taking a 5 out, and I'm going to get 3/2. So that means that the bigger one, WXYZ, is 1.5, 3/2, times bigger. So I can take the scale factor and multiply that by 12, because that's the other side. It needs to be 1.5 times bigger than that. Cross reduce here, and I would get 3 times 6 is 18 as well. You can do either one. Sometimes the scale factor is really easy to pick out, and sometimes it's not, so the proportion is a nice way to go there. In slide 7, similar pictures, finding different lengths. Excuse me, finding different measurements. So find a WZ. So we need to find this one over here, and then find AB. Okay, well, we know right now that the scale factor is 3/2, so I'm going to use, for B, I'm going to use a proportion. So you see that again. And for AB, I'm going to use the scale factor. And we can think of the scale factor as either 3/2 if we're going to the bigger one, or 2/3, just the opposite of each other, the reciprocals. So A, to use a proportion, we got to find WZ. So what do I know? I know 10 and 15. So I'm going to go little over big equals WZ. Little, so 13, over WZ. I'm just going to call it X. Cross multiply, I get 10X equals 15 times 13, 195. Divide both sides by 10 to solve my one step, and I would get that X is equal to 19.5. Or we should actually not call it X anymore. We should call it WZ. Okay, here we go. Now B, sorry, that was B. Now I'm doing C over here. C, I'm going to use a scale factor. To find AB, I know that that's either 3/2 or 2/3 the size of the other one. It's a smaller one, so I'm going to say it's 2/3 of the bigger one. Well, we know that the bigger one side is 24. So 3 goes into 24 8 times if you need to set it up as a fraction. And then we're left with 2 times 8, which is 16. And that's how we could use either a proportion or a scale factor to get us some missing sides. If plan A fails, remember that you have 25 letters left. Have a great day.